This is the first time I'm speaking at a conference, and I really wish I could have attended the Node.js in person, but due to some logistical issues, I was unable to travel to Italy. Maybe next time. I'm pretty excited nonetheless. I hope you guys are too. So let's begin, shall we? In this talk, I'm gonna be talking about how GraphQL overcomes some of the major limitations of REST. Post that, we'll discuss some points on the case against GraphQL so you can have a clearer idea of whether you need GraphQL before you jump into using it at work. Also, a slight disclaimer, I'm going to be sharing all that I'm sharing about GraphQL as a fellow student. So I'm learning, as you all are. But I think it's worth it to share the knowledge I've acquired until now with a larger audience. Also, I think this is one of the most productive ways to disagree. So I'd love to hear from you guys once I'm done with this talk. Alright, so I'm Supriya and I'm gonna be giving the rest of my introduction later at the end of the talk. You'll see why. So before we begin, let's first see what GraphQL is, because I'm not sure if each one of you would be familiar with it, given that it's a relatively new technology. So I'm not gonna dive very deep into what GraphQL is or how it does what it does, but I'm gonna tell you enough so that you don't feel lost during the remainder of the talk. So, what is GraphQL? GraphQL, as on Wikipedia, is a data query and manipulation language for APIs. What does that mean? It basically means that it is a language for requesting data from your server. So now, the next logical question should be, REST APIs are doing that for me. What do I need GraphQL for? Which is what the first part of my talk is about. Why GraphQL? What are the limitations of REST that GraphQL tries to overcome? Now, I'm an avid traveler, so this right here is my favorite analogy for a comparison between REST and GraphQL. Now this pie chart depicts REST. It is like those of us who like to carry our entire wardrobes when going on a vacation, even though we know we are gonna use only a handful of the items. That's exactly what one of the major limitations of REST is. You either get the entire object you requested for with all its attributes as a response from the server, most of which goes unused, or you have to create multiple endpoints if you need only specific data. If you've used REST, you'd know how it works. So, if you have an endpoint like /wardrobe, it will ask you to pack all your items without letting you choose. But with GraphQL, you have a single, sort of a multi-purpose global endpoint. Again, let's say we call it /wardrobe. But the difference in this case would be that you can choose what items from the wardrobe you want without actually having to create a separate endpoint. So now with REST, you have these rigid server-defined endpoints that give you a sort of predefined set of data. And more often than not, there's either overfetching of data or underfetching. And you have to make multiple round trips to fetch related resources. In case there's underfetching, you'll have to make multiple round trips to get similar data and then collate it. So continuing with our wardrobe example. Let's say we have one endpoint that gives us clothes suitable for Italy and another one that gives us clothes that can be worn during winter. And we want clothes that we can wear in Italy in winter. To achieve this with REST, we would either have to create a new endpoint or make 2 calls, and then do an intersection on the data returned. Or we'll end up carrying summer clothes as well, which will just be extra luggage. But with GraphQL, you get only what you need. No more, no less. The client can type in their request and choose what data or what attributes of a particular object they want. And GraphQL would return only those, as opposed to the entire blob. There's a schema that needs to be defined in order to be able to do this, which is nothing but sort of like a blueprint or a catalog for all your objects and their attributes. So with this schema, the client knows what data exactly it can get from the server. And this schema also serves as an instant and amazing documentation, because you just show the schema to the client and it knows what data it can get from the server. And also, there's only a specific format for sending queries. The request data that the client needs. To request data, the client sends a JSON-like query describing what it wants from the server. So it can just go and be like, hey, I need winter clothes for Italy, or hey, I need summer clothes for Hawaii. And the server will respond only with the requested data instead of sending the entire blob. Now, coming back to one of our previous points, with REST, as I mentioned earlier, there is overfetching of data. The client receives a lot of data from the server which it might never use, just like those extra clothes we take along for a vacation. Now, this definitely affects performance because of the whole blob of futile data that is being transmitted from the server to the client. And second, it can also be a security risk if the API developer, by mistake, introduces a sensitive field, which no doubt can be mitigated. But why send it to the client in the first place? So, in a nutshell, GraphQL provides you with instant documentation in the form of a schema, solves the problem of data being either overfetched or underfetched, which in turn reduces the number of requests you have to make to your server. So now that you know why GraphQL, let's look at some use cases of GraphQL, why you might want to use GraphQL. So these are some of the common ones. The first one is if you are building an application that is sort of like multiple data sources, you might want to use GraphQL. The second use case would be if you have a set of data that is needed across clients, across multiple applications. So now that you know what the benefits of GraphQL are, you might want to jump right in and start using it in your applications. At least that's what I had done last year when I got introduced to GraphQL. I got pretty hyped up and immediately decided that I needed to build a prototype for a part of the application I was working on using GraphQL, without giving much thought to what the consequences might be. I learned some lessons from the process, and right now I'm gonna share those with you. So let's move on to the next part of our talk, why not GraphQL, which is sort of a misnomer, as you'll realize as we go through the remainder of our talk. Now, there are certain drawbacks to using GraphQL, which need to be given a thought before any organization or individual decides to overhaul REST and start using GraphQL. Now, while we are going through these, we are gonna realize that Some of these are the exact same points that we saw while going through the benefits of GraphQL, but this time they will be put forth in a different light. The first thing that we need to look at is that GraphQL is new, which, without a doubt, is true for any technology that comes up. But we need to weigh the benefits with the cost every time. So, if an organization decides to adopt GraphQL, it would need to teach its employees about it. And I'm not saying learning is a bad thing, there's nothing wrong with learning. But sometimes the payoffs with learning are uncertain. Not to mention, it takes time and has an opportunity cost associated with it. Also, it is not wise to switch to a technology just because it's new, right? Also, since it's new, it needs time to mature. Now, the most battle hardened implementation of GraphQL is in PHP because that's what Facebook uses. And as you all must be aware, GraphQL was developed internally by Facebook in 2012 before being publicly released in 2015. Now, that implementation is not available for use. It's neither available as open source nor commercially. Only GraphQL JavaScript is available. But what if your technology stack doesn't include JavaScript? You are not using JavaScript in your applications. What library do you choose then? Let's say you choose Java. That's what I had used because I code majorly in Java at work. It raises a few concerns. The first one being, is it production ready? Second, does your organization have the resources to handle incomplete and evolving implementations of software in production? Now, the second thing we need to look into is cargo culting, which means doing something just because someone or something successful is doing it. For example, we see that Amazon uses microservices and Amazon is successful. So, we'll make ourselves believe that microservices cause success. A similar case with Facebook and React. And here, I'm not denying the fact that large companies do create amazing and useful technology. What I am trying to say is that using that technology without trying to understand the context and the cost is futile. So let's take a look at Facebook's use case. Why Facebook is using GraphQL? Now, Facebook has millions of users in a lot of developing parts of the world with low quality mobile networks, data caps, and devices that have limited capabilities on the client. At that scale, even minor efficiencies improve the company's user growth, which is the main metric that Facebook is trying to optimize. But as we all know, there are only a handful of companies that have that kind of problem at that kind of scale, which means you need to first identify what you want to achieve by moving to GraphQL, as opposed to using it just because Facebook is using it. Now, let's assume you found a valid use case for your organization or for your application, and you have actually started implementing GraphQL. There are new problems that are gonna arise now, which you didn't think of before, because you only knew how GraphQL was better than REST. That's what everybody talked about. The first of those new problems is control. As I mentioned in the first half of this talk, with REST APIs, the server has all the control. The server decides what and how much data to return to the client. But GraphQL inverts this. It puts the client in control. Now, when we were talking about the benefits of GraphQL, as you might remember, we were really happy about it. We were really glad that the client gets to decide what data it wants. But imagine that in your application that you built using GraphQL, you have a flat cost per API call. Now, if you make two different queries to that API, these queries can have a dramatic cost difference in GraphQL on your backend. Why? Because the client can send an arbitrarily deeply nested query. And in that case, it will take a lot of cost to fulfill it than for a query which is relatively simple. And the thing about this is that you have no control over what the client wants from you. This problem can be dealt with. There's a mechanism called persistent queries, where you whitelist a set of queries that are allowed to be executed. And you create this set in advance, and you could isolate the problematic queries. You could tell the client that this particular set of queries is not allowed. But what if you're building a third-party API, an API that is gonna have multiple clients, multiple applications that use it? In that case, I'm not sure if persistent queries would make sense. Each one of your clients will have different requirements altogether. The second thing you can do to resolve this issue is limiting the query depth. But again, that might make it difficult to execute queries which are legitimate and would have worked had you not put a check on your depth. Now, the second problem that you might face would be that of centralization. Now, as we saw earlier, the GraphQL schema is sort of a catalog or blueprint of object types, their scalar fields, and their relation with other object types. But more than just a list, it's also a consistent snapshot of your API, what sort of requests it can process, what sort of data it can return. And it includes very common sense rules, like you shouldn't have two types that are named exactly the same thing, obviously, because that would cause conflicts. But what would happen if you try to follow this in a very large code base? You can get naming congestion. And naming, as we all already know, is hard enough already. Now, you need to choose a name that is not only expressive but also unique, which would not have been a requirement otherwise. Centralization also introduces problems when it comes to federation. What federation means is that you have multiple different GraphQL APIs that your organization might own, and you want to create one consistent GraphQL schema that describes all of them. This is the first case of federation. The second would be when you have a single GraphQL API, but that API spans GraphQL endpoints owned by multiple different organizations. Imagine the World Wide Web as an example. Imagine if it was used as one giant GraphQL API. What would the query look like? What would the schema look like? We would have to describe all the types of all the websites ever known, and those would have to be consistent with one another, which clearly shows that centralization is difficult at large scales. Now, GraphQL's central organizing concept is a graph, obviously, as the name suggests, which is a very powerful thing. But it's different from a resource. And resources are what REST is based on. Because of this, there are a few features that you have in REST, but not in GraphQL. Now in REST, when you fetch a resource, the response returned includes hypermedia links for you to modify and delete that resource if you are allowed to do so. If you want to do this with GraphQL, you need a list of all the queries and mutations that affect that type. And mutations are nothing but sort of a way to update data, similar to put and post methods in our REST APIs. Yes, but GraphQL has no such feature. Now, another problem would be that of the ORMs, the object relational mappings. Most object relational mappings today have been built to work with the REST architectural style. But because of the way resolvers in GraphQL work, before I move on, a resolver is nothing but a function that resolves GraphQL queries. Yes, so because of how resolvers work, if you're already using an ORM, an object relational mapping, and you migrate to GraphQL, chances are that that ORM is not prepared to work with GraphQL. It's not prepared to work with you. Now, the next issue that might arise would be around your tech stack. So, your decisions about the stack to use around GraphQL might lead to unthought of consequences. One example would be that of custom scalars. Custom scalars are sort of custom defined data types other than the inbuilt ones that GraphQL already provides. So GraphQL includes a number of basic data types like string, integer. But what happens when you want a custom data type like long and date, which are quite common in all other languages? Let's look at long. A lot of languages, as I said, already have a long data type, which is a 64-bit integer. But in GraphQL, integers are 32 bits and floats are 64 bits. So in theory, while using GraphQL, you should be defining long as a custom scalar, as a custom data type. But more often than not, people just use float instead, which makes the API ambiguous. A similar problem is impedance mismatch, which is the phenomenon where the type system of your database and the type system for your application logic differ in subtle ways. When you put GraphQL in front of the application logic, it might not necessarily line perfectly with your server-side code or your client-side code. Now, finally, coming to the performance. Now, the REST responses have cacheability, and it's mandatory for them to use standard headers like last modified by to indicate how the response should be cached. And these headers are interpreted by intermediate proxies on the way to the client to create optimization. However, with GraphQL, the response has no such constraints or restrictions. Because of this, You don't have an automatic way to translate a GraphQL response into these headers. And depending on the latency between the client and the CDN, then you might have situations where maybe, just maybe, multiple round trip requests are actually more performant than a cache miss against the nearest CDN. Also, there might still be some overfetching even with GraphQL. I know that we just talked about how GraphQL eliminates overfetching, and it's intuitive as well given the way GraphQL works. But it still might happen. Let's see how. So, going back to our wardrobe example, if I have a wardrobe schema and if I create a query against this called get wardrobe details and then create another query elsewhere in the application that fetches the exact same data, then I get a duplicate type of query. Two queries, two types that have the exact same fields to fetch. There is a solution to this though, a thing called fragments, which is sort of a predefined query that you can use multiple times, again and again. But if you're lazy and you need details which are very similar to a particular fragment but not exactly the same, you might fetch everything, causing overfetching. And if you're not lazy, you will create two fragments where you fetch different data, distinct subsets of the fields, but with very minor differences. These fragments, no doubt, would be more granular, but this would create two different types. At Facebook, they call this the type model versus the fragment model problem. So, those are the problems that I face that I wanted to share. So finally, what I'd like to say is that GraphQL seems really easy and simple at the first glance, but it starts losing its simplicity when you start worrying about client-side state management, query persistence, etc. Having said that, GraphQL and REST are not mutually exclusive. You can have some parts of your application use REST and some use GraphQL. And I'm not saying that you shouldn't use GraphQL. You should definitely go for it, but only after making sure that you've figured out the solutions for the problems that I just mentioned. And those solutions, I can assure you, do exist once you start looking for them. So, thank you. I'm Supriya, and finally, here's my introduction. I'm a software engineer, and I spend most of my time programming either in C++ or in Java. I love the spring season, traveling, as I mentioned before, pigs, penguins, and pineapple on pizza. That last bit, pineapple on pizza, is why I didn't introduce myself before, because the conference is in Italy and I'm not sure how people would have reacted to that statement here in the birthplace of pizza. Now, if you have any questions about what I just spoke about or you have any disagreements, feel free to reach out to me at this given email or send me a message on that embarrassing Instagram handle. And that's all from my side. I hope you all are enjoying the conference. Bye.